Just about any course that you're going to see that talks about recursion is going to use Factorial as an example of how to use recursion. So what is a factorial? This is 4 factorial, is how this is pronounced. And what it is 4 times 3 times 2 times 1. So let's bring this up here and look at why it's such a great problem for recursion. These last 3 numbers, 3 times 2 times 1, is equal to 3 factorial. So you could say that this is 4 times 3 factorial. And 3 factorial, that's the same as saying 3 times 2 factorial. And 2 factorial is the same as saying 2 times 1 factorial. And 1 factorial, well, this is just 1. This one's different. This is our base case. Once we get to 1, we can stop doing this breakdown that we just did here. One of the things we've already said about recursion, and we saw this in the gift box example, is that each gift box has to be getting smaller and smaller until you finally get to what it is that you're looking for. So getting to that 1 would be the equivalent of getting to the ball. So I'm going to shrink this down here so we have some room for some code. And I'm just going to bring the code in. It's kind of hard to go through a recursive function line by line. So I'm just going to bring this in, and then we can talk through how this is going to work. So our function is going to be factorial. We're going to pass it the number 4. That's going to be the n. If we ever get to the point where n is equal to 1, we're just going to return 1. So n equaling 1 is this right here. N equals 1. We return 1. Otherwise, we're going to return n, in this case 4, times factorial of n minus 1, which is going to be 3. So we could look at it like this. It's 4 times 3 factorial. So I'm just going to put this code up in the corner right here, and then we will walk through this step by step. We're going to run the factorial function, and we will pass it the number 4. Then we're going to go back up to our function here and look at that if statement. If n equals 1, we're going to return 1. That's not the case. N is not 1, it's 4. We're going to return n times factorial of n minus 1. And that is going to look like this. And we're going to put the 4 and the 3 in there like that. And then we're going to do it again. Is n equal to 1? Well, it's equal to 3 now. So we're going to do the same thing. Like that. And now we're going to have 3 and 2. Then we look at our if statement again. Is it 1? Well, we're getting close because it's factorial of 2 there. And now we're going to have to do this again. And we're going to have 2 and 1 in there. Now when we look at this if statement, n is equal to 1, so we can return 1. So the 1 is this one here. So I'm going to remove this, and we're going to look at these steps here. So the return 1, that's being returned to this function. It's been waiting for this to return. Now this can calculate 2 times 1, and it can return 2 to here. And that becomes 3 times 2. Then we can return 6 to here. And then 4 times 6 can be returned to the original function call, which is 24. Now let's just walk through this. 2 times 1 is 2, and we return that here. 3 times 2 is 6, and we return that here. 4 times 6 is 24, and we return that here. And that's our answer for factorial of 4. So let's look at this yet another way, the gift box method. This was factorial of 4, and that called factorial of 3, and the boxes get smaller and smaller, and instead of having a ball, we have 1, and we return the 1 up to here like this. We return 2 up to here like this, and 6 up to here like this, and 24. And I'm going to go over this one more way because recursion is one of those things that you have to look at it a few times to be able to get it. This is with the call stack. We're calling the call stack with factorial 4. And then we have factorial 3. And then 2. And then it's calling it with 1. So then 1 is going to return an item to 2, which means it's done running. And 2 is returning something to 3, and then when it's done, it pops from the stack. Now 3 has that value. It does what it needs to do, passes that to the 4. That gives you the 24, and that one gets popped from the stack. So now let's go over and look at this code in Chrome DevTools. Okay, so there is our code there. We're calling this with the number 4. We can zoom out here, run this, and then down here we get 24. I'm going to clear this. And then what I'm going to do here is I'm going to open the debugger and I want to show something. And that is when I create a breakpoint here. Now I'm going to run this. So our call stack, as we step through this, we're going to have factorial put onto the call stack. That's factorial. And you can see up here that n equals 4 up here. But on the call stack itself, it just says factorial. And then we run through here, and it's going to call another instance of the function. So I'm going to click this, and now we have factorial on the call stack a second time. It will show you that n is equal to 3 this time. But the call stack itself is just showing factorial twice. And I'm just going to step through this. N equals 2. N equals 1, and we have factorial on the call stack 4 times. So you can't tell by looking at the call stack which one of the factorials it is because they all just say factorial because we're calling the same function over and over. But watch this. If I click on this, n equals 1. If I click on this one, n has been changed to 2 and 3 and 4. So they do include that on what the argument was that you passed to this. So we'll just step through this. Now you can see that it's highlighting that if statement is going to return 1. And we have popped that first item off the call stack. So the one at the top of the call stack is the one for the number 2 now, and 3, and 4. And then when we pop this one from the call stack, the only thing left is to return the number 24 down here at the bottom. Okay, so I wanted to do one more thing here. And factorials, it's amazing how fast they grow. So factorial 4 is 24. But if you go to factorial of 8, this goes all the way to 40,000. If you go to factorial 20, you get this really huge number here. So they grow very, very fast. So it's a fun function to play around with and see how fast those numbers grow. And that is our overview of factorial.